In this video, we will look at factoring a sum and a difference of cubes. So let's first take a look at what that looks like. What is a sum of cubes? Well, we have here a sum, because it's addition, of two things or two terms that are cubes. And these happen to be perfect cubes. Or we may have a difference of two things that are cubes. Okay? So these factor in very specific ways, and we have them factored here. So notice that if I have a cubed, this first term here, and I actually cube root an a cubed. Those are opposite operations, right? We cube something, then we cube root it. We're back to a, right? Just as a reminder. So this is actually the cube root of a cubed. When b will be the same, the cube root of b cubed is b. So that will happen every time in one of the factors, and we usually write it first. The cube root of each of the cubes, a plus b. And notice that it's a sum in both, okay? Now in the second factor, which turns out to be a trinomial, we begin with that value a squared, then the opposite sign, it's a difference now, the product of a and b plus b squared. Okay? In a difference of cubes, we get the very same pattern. Notice that if I cube root my a cubed, I get a. If I cube root my b cubed, I get b, and it's a difference in both cases. A sum is the first sign here. And notice that the a goes to a squared, the b goes to b squared, and the product ab here. One other thing we want to note is this is always a positive, okay? Because we're squaring something. Doesn't matter whether it's negative or positive. It's turning out positive all the time. So that's the pattern we're watching for when we are factoring a sum or a difference of cubes. So let's try one. Notice that we have here a difference, okay? So we're looking at, and in fact, let's just scroll this down a bit. We're going to use the difference of cubes formula. So we're that's going to be our first term. And this is going to be our second one. So let's find out what the a and b will be in these cases. So for the first term, x cubed, if we cube root x cubed, we get x. And for the second one, 8. If I cube root 8, I get 2. It's a perfect cube. So now we know that this will be our a, and this will be our b. And we are ready to fill in the rest, okay? So we first have the first factor here, a minus b, x minus 2. And in the second bracket, a squared, so that's x squared, plus, right, the opposite sign of that, a times b, which is 2x, plus b squared, which is 2 squared, or 4. Let's write 2 squared first. And then I can simplify it. I could have done it right on that line, but I just wanted you to see where the 4 comes from. Okay, so double check a couple things. This should match the one in the first bracket, and we should have the opposite sign here, and this one is always positive, or always addition. Okay, factored. Let's try another. In this case, we have a sum of cubes, and we don't always know it's cubes, or it won't always be perfect cubes, but we do know that we have two terms where we have a cube on the x. So this is possibly a perfect cube, and another one possibly a perfect cube, and we have a sum in between. So it's a sum of cubes. So let's see about, we need to find the a and the b, right, by cube rooting. So I have 8x cubed, and I'm going to cube root it, right? Well, the cube root of 8 is 2, and the cube root of x cubed is x. So there's my a for the formula, okay? Let's look at the next one. We have 1,000, and we want to cube root it. What multiplied by itself equals 1,000? Well, that is 10, so that's our b. Well, we're all set. We've got the a and the b, so now we know what to fill in for the rest of the factoring formula. So let's make this going to be 2x plus 10. It's a sum. And in the next one, we need to do, let's do a different color bracket just to let it stand out, okay? 2x squared, that's our a squared. It'll be the opposite sign minus ab, 2x times 10. I'm just going to write it like that for now. Plus, it's always an addition, b squared, which in this case is going to be 10 squared. Okay. Notice I filled in a and a times b, and b gets squared. Okay. So let's simplify this a little bit. 2x plus 10. When we square 2x, it becomes 4x squared minus 2 times x times 10, which is 20x, plus 10 squared, which is 100. And this sum of cubes is factored. Now, if you noticed last time, we had perfect cube added to a perfect cube. And sometimes that's not always the case. So let's see. 3 is not a perfect cube, like the 8 was in the last example. So, but this one is. And this one's not a perfect cube, 192. So let's take a look. Sometimes we need to remove a common factor first. And let's see if 3 or x cubed or anything is a common factor of each term. Now it can't be x cubed because there isn't an x here. So the x will not be part of a common factor, but possibly 3 is, okay? Let's factor the 3 out. In the first term, we're left with x cubed. And for the next one, I must do 192 divided by 3 is 64. All right? Now, when I look in my bracket, do I have a perfect cube and a perfect cube? Is there anything that when multiplied by itself 3 times is equal to 64? And yes, actually. So let's work on that. Remember that for the first one, x cubed, if I cube root x cubed, again, we get x. And for the second term, if it's a cube root of 64, is equal to 4. So we do have our a and our b for the formula, okay? And it is a sum. So let's take a look at that. Remember, we factored out a 3. Don't forget that, okay? 3. And now this will be, the first bracket is the a plus b, which is x plus 4. And the second bracket, is a squared, which in our case is x squared, and the opposite sign, so it's a minus, and then it's a times b. Well, that's x times 4, so that's 4x, plus b squared, which is 4 squared, which is 16. Okay, we'll just put a quick little note that that's equal to 4 squared, so you can see where that came from. And that's factored. And that's all. Thank you for watching.